Hi friends, this question is from test series 12. Subject name is OS and the topic name is memory management and virtual memory, and it is of 2 marks. Let us see the question. Assume we have a demand based memory. The page table is held in registers. It takes 10 milliseconds to service a page fail if an empty page is available or the replaced page is not modified, and 20 milliseconds if the replaced page is modified. Memory access time is 100 nanoseconds. Assume that the page is to be replaced is modified 70% of time. What is the maximum acceptable page fault rate for an effective access time of not more than 200 nanoseconds? Option A 5.9 into 10 power minus 6. Option B 6.2 into 10 power minus 6. Option C 4.7 into 10 power minus 5. Option D 3.5 into 10 power minus 5. Given memory access time as 100 nanoseconds and the effective access time not more than as 200 nanoseconds. In order to calculate the effective address, there is a formula like this: P into PS fault rate time plus 1 minus P into MA, where P is nothing but page fault probability and MA is nothing but memory access time. Here we have to find out the page fault time. In order to find out the page fault time, see how to calculate this one. Here we have to take two ways. That means if the page is replaced and the page is modified. So there are two cases in this one. So if you consider this one, here 0.7 is there na. Here if this 0.7 in problem, it is given as page which is to be replaced is modified, and if you see this 20 into 10 power minus 3, which is nothing but 20 nanoseconds, it is given as replaced page modified time. Replaced page modified time. And if you see this 0.3, it is nothing but page is not replaced. And this 10 into 10 power minus 3, which is nothing but 10 nanoseconds, it is time. In problem it is given as 10 nanoseconds it takes to service a page fault if any empty or replaced page is not found. If the replaced page is not modified, then it is the time to access that page. So this is, if you calculate this one, you will get it as 17 into 10 power minus 3. In order to find out the page fault time, you have to take two consideration: if the page is replaced and if it is modified or not. Based on those two conditions, we have to calculate the page fault time. And if you consider after calculating this one, we have to substitute these values in the effective address. And here, if you see this problem, here they mentioned as the maximum acceptable page fault rate we have to find out for an effective time of not more than 200 minutes. So it should be less than or equal to 200 nanoseconds. So 200 into 10 power minus 9, P into 17 into 10 power minus 3, which we calculate as page fault time, and 1 minus P into 100 into 10 power minus 9, which it is nothing but memory access time. So 200 into 10 power minus 9, which is nothing but effective address. So if you calculate this one, we will get the value as 5.86 into 10 power minus 6. The nearest answer for this one is 5.9 into 10 power minus 6, which is nothing but option A. From this question, we got to know how to find out the effective address and how to find out the page fault maximum acceptable page fault by using effective address, and how to find out the page fault time using two cases: whether the page is replaced is modified or not, and the page is not replaced or not. Thank you.